Right, this will be a video for page 92 in your 7th grade math book. We're going to be doing division. The word quotient here. Quotient is the answer to a division problem. So we're going to be doing division, and you should notice here for number 1, it looks like I have decimals in the form of a fraction. But remember, any fraction can be interpreted as division. So this first problem here, number 1, this is 0.72 divided by negative 0.9. And I just got rid of those zeros because I didn't want to write them. So this is a division problem. And when we're going to divide out decimals, sometimes you can just tell that I know that 9 times 8 is 72. So my answer is going to be something like 8. But when we throw in these decimals, it makes it a little trickier. So let's go ahead and write it out as a standard division problem over here. So we'll have 72 with a decimal, so 0.72 divided by 0.9. And the first thing we need to do is move our decimal. Move decimal. And the way we do that is we're going to take this number that we have here on the left. We're going to take our divisor here, and we're going to move our decimal to the far right. So we moved our decimal 1 time. And I'm going to do that same thing here. I'm going to move my decimal 1 time, which makes my decimal end up right here. Okay. Now, I'm just going to solve this like a normal division problem. So how many 9s are in 7? Well, there's none. We can't fit 9 in 7. 9 times 0 is 0. We'll subtract 7 minus 0 is 7. Bring down this 2. How many 9s are in 72? I know that 9 times 8 is 72. So that'll be an 8. And 9 times 8 is 72. And I'll subtract, and I'll get nothing, and I'm done. So my answer then is going to be 0.8. Okay? So we just have to make sure we move our decimal as our first step when we're dividing decimals. I'm going to skip number 2 for a minute. I'm going to end number 4. I'm going to just do the decimal ones here first, just so that we're consistent and doing the same things here. So the next one, let's see, we're going to do, we might as well do, actually, I guess we're not quite done with this problem, are we? This was 1 negative. This is going to be the same rule as we had with the multiplying with negatives. If there was 1 negative, then our final answer is going to have to be negative. If there were 2, they would cancel each other off. But in this case, we have 1 negative, so our final quotient is negative 0.8, or negative 8/10. Number 3 is 56 divided by negative 7. Now I know that 56 divided by 7 is 8, because 7 times 8 is 56. So for this one, it actually is just going to be, we just got to make sure we get that negative in there. It's going to be negative 8. Fractions, we're going to skip it. Fractions, we're going to skip it for a minute. Let's do number 6. We've got negative 91 divided by 13. Now, if I set this up with standard division again, let's do that. Let's do, so we've got 91 divided by 13. How many 13s are in 91? I'm not really sure, so let's go ahead and do 13 times, I don't know, how about 6? Just a random number. 6 times 3 is 18. 6 times 1 is 6, plus 1 is 7. So that was times 6. Well, let's add another 13 and make this times 7 instead. So I've got 8 plus 3 is 11. 7, 8, 9, 91. So that's going to be 7. 91, subtract, done. Okay. So let's check this out. We've got 7. We've got a problem with negative on the numerator, negative on the denominator. We've got negative divided by negative. Those two negatives are going to cancel. It's going to give us a final answer of just 7, positive 7. Let's go ahead and do number 8. Number 8 says this negative here is in the front, but it's the same thing as we had on number 1 and number 3. It's just there's 1 negative in this problem. Okay. So this, I know my final answer my final quotient is going to be negative because there is one negative there. So let's do that. Let's do 12 divided by 0.03. Look at my number. Step 1 is to move to decimal. So let's go 1, 2 times over. On the number 12, the decimal point is at the end. It's 12 wholes. So I need to move my decimal over 1, 2 times to here, and then move it straight up to here. And I'm going to move this line I'm going to extend it all the way over here. And in those blank spots, I'm going to add some zeros. So let's see. Now this is the number 3. How many 3s are in 1? Well, that's nothing. But how many are in 12? There are 4. 4 times 3 is 12. Subtract 0. But I'm not quite done. I have another 0 to bring down. 3's in 0 is 0. 0, subtract 0. Bring down another 0. 3's in 0 is nothing. 0, subtract 0. Done. And if you just recognized that and added 2 zeros, that would have been fine too. So this is going to be negative 400. It looks like on the next 3, the 3 word problems, I have decimals as well. So I'm going to clear some of this work out so I can fit a little more. All right. So that was step 1 over here. All right. So number 9, a water pail in your backyard has a small hole in it. So you've got a water bucket, it's got a hole in it. You notice that it has drained about 3.5 liters in 4 days. What is the average change in water each day? So I'd kind of think about this like this. The whole time it goes down 3.5 liters, and that's over a total of 4 days. So that's 4 days. So I want to see how much happens each day. So we've got a day here, we've got a day here, right? Day. We want to find out, we want to break this into 4 different groups and find out if this happened over 4 days, what happened each day. So let's do negative 3.5 divided by 4 days. How many? There's no decimal to move here. The decimal is in the right spot. How many 4s are in 3? Well, that's none. 0 times 4 is 0. That brings us to 3 minus 0. It's going to be 3. Bring it down to 5. I'm going to make sure that decimal goes straight up before I forget it. And a 4 times 9 is 36. So this is going to be 4 times 8, which is 32. Subtract. I've got 5 minus 2 is 3, and that makes it 0. Well, I'm not done, so I've got to add a 0 and bring another 0 down. So there's a 0. 4 times 7 is 28. Subtract. 30 minus 28 is 2. I'm almost done. I know that 4 times 5 is 20. And that marks our end here. So the average change in water volume each day is this many liters. And we got to make sure it's negative because we're losing water. We're doing negative 3.5 divided by 4. So the average change is negative, about negative 0.875. And it is a word problem, and we need a label, liters. If you choose to use a capital L, that's fine as well. All right. Number 10, the price of 1 share of ABC Company declined a total of $45.75. So it's $45.75 declined. That's negative over a total of 5 days. So there's 1, 2, 3, 4. So 1 day, 1 day, 1 day, 1 day, 1 day. We need to know what is the average change of the price of a share per day. So we need to take this number and divide it into 5 groups. So we're going to have negative 45.75 divided by 5 groups. 5's in 4, and that's nothing. Nothing, subtract 4, bring down my 5. 5's in 45. Well, I know 5 times 9 is 45. Subtract 0, bring down a 7. 5 times 1 And I noticed that I didn't bring this decimal up, so I'm going to do that right now. 5 times 1 is 5. Subtract. I get 2. Bring down my last 5, and this is going to come out even. 5 times 5 is 25. Subtract. I get 0. So I have the answer here, 9.15, and it was declining, so I have to have a negative. It went down $9.15 each day. Make sure it's negative. Make sure you have a dollar sign because that's our label on this problem. For the next one, to avoid a storm, a passenger jet pilot descended, that means goes down, 0.44 mile or 44/100ths of a mile in 0.8 minutes. What is the average change in altitude per minute? So what we're going to do on this one is we're going to do 0.44 and we're going to divide that by 0.8. And we're going to find out what happened per minute. And this, the way I think of this is I know that I go 0.44 of a mile in 0.8 minute. So if I'm going to go in miles per minute, I have to have miles as my numerator, minutes as my denominator. And I'm going to solve this division problem. So I'm going to rewrite it over here so I have enough room. So I've got 0.44 divided by 0.8. So step 1, I do have a decimal to move on this one. Move it once, and bring it straight up. So how many 8s are in 4? None. How many 8s are in 44? 5. 8 times 5 is 40. Subtract. I have 4, so I'm not done. I've got a 0 to bring down. 8's in 40, again, is 5. 8 times 5 is 40. Subtract, and I am done now. So this is, remember it's descending, so it goes down 0.55 miles per minute. Okay. So we set it up in a fraction of miles divided by minutes, and we do 0.44 divided by 0.8. First step there was to move our decimal. The rest of these problems are going to be fraction division problems. And I think once we do 1 or 2 examples, you'll probably be like, oh yeah, I remember doing that last year. I remember doing that before. So on this one, so this is decimals. Step 1 was move the decimal. Step 2 is divide normally. So that was how to do decimals. Now for fractions, the first thing we're going to do, well, I'll go ahead and show you on number 2, and then we'll write a couple rules for it. So we've got, look at this crazy thing. This is a fraction inside of a fraction. So I want to just rewrite this as a division problem. So I have negative 1/5 divided by 7/5. Okay. So I have 1/5 and I have 7/5, and this is a division problem. It's a fraction and a fraction, but it's really just a division problem. Now, in the past, well, what we want to do is we want to find out how many 7/5 are in 1/5, and it's going to be a pretty small number because 7/5 is bigger than 1/5. So if I asked, like for example, if I asked how many 10s are in 1, well, there aren't any 10s. There's a lot less than, or how much of 10 is in 1? That'd be 1/10. So it's a really small fraction. On this one, it's again going to be a really small fraction, but the trick here is to keep, change, flip. So we keep this fraction the same. We keep this. So this will be 1/5. I'm going to put my negative. We change this division to multiplication, and we take this fraction and we flip it. So that'll be 5/7. Okay. So this, the reason this works is because instead of dividing, we're we're going to be using the inverse of division. The inverse of division is multiplication, but if we do that, we have to use the inverse of our fraction. The inverse of division is multiplication. I'm going to write the word multiplication. And the inverse of this fraction is its reciprocal, where we just flip that fraction upside down. Okay, so if it was 7/5, now it's 5/7. And now this is a multiplication problem, which we've done multiplication with fractions. I see that I have a 5 on the top and on the bottom. I have a 5 in the numerator and a 5 in the denominator. I can reduce those to 1 and 1. So now I have 1 times 1 is 1. I have 1 times 7 is 7. I have 1 negative, so my final quotient is going to be negative. Number 4, I'm just going to rewrite this as a keep, change, flip already. So we keep the first number, 251 fourths. I change this to division, and then I flip to negative 8 thirds. I see a 4 and an 8, and I know those are compatible. I can divide those both by 4, so that 4 will turn into a 1, and the 8 will turn into a 2. And I know that I'm willing to bet these two work together too. So let's do really quick over here, just some scratch work. 251 divided by 3. 3's in 2? No. 3's in 25. I know 3 times 8 is 24. Oh, this isn't actually going to work, is it? These aren't compatible. So this is 1 and 1. 3's in 11. So this actually doesn't even work. So we've got 251 times 2. I can't reduce this fraction. So we've got 251 times 2, because this 11 didn't come out to a perfect answer. If this was 12, then it would be 84. But nope. I thought it would work, but it doesn't. We can't reduce that. So my answer is going to be, I have 1 negative, so it's got to have a negative. 251 times 2, let's see. 251 times 2, 1 times 2 is 2, 5 times 2 is 10, 2 times 2 is 4 plus 1 is 5, so I have 502. And I probably would have just done that in my head. I would have done 250 times 2, which is 500, and I would have done 1 times 2, which would be 2. So we have 502. In the denominator, I have thirds. So 502 thirds. And this does not reduce this. This is our final answer. I'm okay with an improper fraction on this one. Because if they started us with an improper fraction, then I'm going to be cool with an improper fraction on this one. Number 5, it's the number 75 divided by 1/5. And I'm going to already do the change flip. So this is change and flip to 5 over 1 that is negative. Now 75 is a whole number, so that is over 1. Okay, so the 1 goes on the denominator. So I have two numbers that are wholes, so my final answer is just going to be a number of wholes, and I need to do 75 times 5. 5 times 5 is 25. 7 times 5 is 35, 36, 37. So I've got 375, and make sure it's negative. Negative 375. Final question. I've got negative 3/7. Let's keep that one. Change this to multiplication and flip this to 4/9. I know 3 and 9 are compatible by the number 3, so this divides by 3 to 1. This divides by 3 to 3. Can't do 7 and 4. They're not compatible. So I have negative 4. 7 times 3 is 21. So negative 4 21sts. So with decimals, the first thing you need to do is write it out like a normal division problem and move your decimal and divide it normally. For fractions, I need you to remember these 3 words: keep, change, flip. You keep the first fraction, you change it, and then you change it to multiplication, and then you flip it to its inverse, to its reciprocal. Okay? It's kind of like negative, negative. If we change this to its inverse and this to its inverse, it's the same thing as what it was originally. 2 negatives cancel each other. 2 inverses cancel each other. So we have the inverse reciprocal. The inverse of division is multiplication. So it's keep, change, flip. And then you can look for your diagonals like we did in our previous section where we were multiplying rational numbers. And then you'll have a reduced fraction.